Hello, Professor. Oh, hello, professors.
Hi, good
Hi.
job. And you got all my instruction and email, right?
Yes, we did.
Okay, and you two planned?
Yes, we did. For the beginning, I believe I'll introduce from Mr. Wilbur, Felix, Ms. Ashley, and Professor Mennella, and then on you will do Dr. James, Dr. Jonathan, and then Mr. Michael Walder. Does that work for you, Anyi?
Are you here, Indamula? Hi, Rocco. I'm so glad to see you here.
Hi, it's good to be here.
Let me just pull up the questions.
Yes, I'm here. Good afternoon, Professor.
Good afternoon.
Good
Yeah,
afternoon.
Nana.
Hey, did you hear what I said of who you're introducing?
No, I didn't.
You'll be introduced in the email that we got sent. You'll be introducing Dr. James, Dr. Jonathan, and then Dr. Michael Walder. And
Okay.
then you'll introduce them. Then, we'll ask them about their personal career journey up into this point in the order in which we're introducing them.
Okay. Thank you.
Yeah, and I sent you a long email today, right? Did you see
Yeah.
that one? Okay.
Yes.
So what we have to do then, I know you will both do a good job, okay? We have one panelist here, but it is okay. He is one of us, so we can talk about it. So that's what we are talking about you, Rocco, okay? You will do a phenomenal job. Think of questions, and I already gave you some, ask them, and later somewhere in between they can do a presentation, but make sure we time it, okay? We be ruthlessly timing. Otherwise, somebody may take 20 minutes. We don't want that. We want them all to interact and so on. Okay, I will be muting myself now so you all can plan. And introduce yourself also, okay? Very nicely.
Of course. Anyi, do you want to go first?
Okay. Good afternoon,
No,
everyone.
not
My name
right
is...
now, not to me.
I was
When all
right.
your panelists
Well, after
arrive.
people were there.
Yeah, yeah.
Okay.
Practice
Okay,
now if
okay.
you want. But after everybody arrives, introduce yourselves, okay? And when you start the panel, you can say, I am this, and we will be the moderators.
Okay.
You are in charge, okay?
All right.
Ashley is coming.
All right. So
Hi,
how should I?
Ashley.
Oh, hi.
Ashley, I'm so excited to see you here. Maybe she will come soon.
Anyi.
Yes.
For the actual, like, how we're gonna introduce, I think I'll just say like what it is. Say I'm a co-student moderator, say, major or whatever, and then you also say co-moderator in your major, and then we'll start introducing the people.
That sounds good.
Okay. Great. And you can access the chat, right?
Yes.
Okay,
Yes.
so I'll text you from there. I'll communicate with you.
Okay. Alrighty. I'm trying to get the work on the
Miss Ashley, I wanted to ask how to say your name, if it's possible. You can hear me?
Ashley is just taking a break. She's finishing another meeting. She posted in chat, and then she's coming in.
Okay. I just wanted to know how to say her last name so I could say it properly.
Rocco knows it.
Oh, okay.
Rocco, how do we say Ashley Henriquez? Is that how we say it?
Yeah, that sounds good to me. Yes.
Okay, and then she will also tell us.
Okay,
She's
perfect.
fantastic too. Okay.
Perfect. Okay, we have 1, 2 panelists.
Oh, yeah. I don't know, maybe I should just put my hair back up so it doesn't fly all over my face. Okay. Oh, Rocco, you are here and you can hear me? Okay.
No, it looks good down. It looks good down.
Okay then. So today's session was great, Rocco, with the heliophysics. The presenter was the Deputy Director of HSD, and our student did a phenomenal job of moderating. I'm so proud to be working with all these students, Rocco. They do such a fantastic job. I
Oh,
am
yeah.
so honored.
No, they do a
These
great
two
job.
are no exception.
Well, we'll find out.
Okay.
Hello, Dr. Tucker. Just to make sure, will you be here for the entirety of the meeting?
Yes, I will.
Okay, thank you. I will private message you.
Okay. And I'm glad to see you, Zareb, here.
Good to see you too, man.
Thank you. So Zareb is our co-host of the meeting, and he is also a student.
I wonder why this thing is not doing the right thing.
Dr. Ransom is just connecting.
Okay.
No, that will just make it nice.
There's side notes.
Hi, Dr. Ransom. Good afternoon. Thank you for joining us.
All right, now you can hear me, I hope.
Yes, we can hear you.
Afternoon. Good to see you again.
Afternoon. Thank you so much for coming again.
No worries.
Mm.
I was hoping to show a video, but I am not really thrilled about trying to do it on my end. I'm wondering if I can send it to someone there.
Okay. That may work very well because we had some problems with sharing on Monday.
Okay, I think we'll just wait like one more minute for our final panelist, just for him to join. Narrator today, my name is Adana Okpa. I am a second-year chemical engineering major here at Prince George's Community College. Oyi, would you like to introduce yourself?
Good afternoon. As I already introduced earlier, I'm the co-moderator with Adana, and I'm also a second-year student majoring in mechanical engineering. I hope to transfer soon, and I can't wait to learn some amazing things.
To get started, our panel today is Careers in Engineering. Our wonderful panelists today will be talking about the many different career paths within engineering, as well as their own journeys with their engineering degrees. And we are joined by some PGCC alumni, so I hope that you guys ask any questions and really interact with our panelists today. Just to go through the list of all the panelists who will join us today, we are welcomed by Mr. Wilbur Dahn. Please excuse if I say your name incorrectly, who is a PGCC alumni and a computer engineer at the University of Maryland in Baltimore City. And we are also introduced by Felix Forcho, I'm so sorry, who is an automation engineer for Merck Pharmaceuticals. And he had graduated with a BS in chemical engineering from the University of Maryland, College Park, and he is also a PGCC alumni. We are also joined by Ms. Ashley Henriquez, who is an electrical engineer in L3 Harris. She is a PGCC alumni who graduated with a BS in electrical engineering from the University of Maryland, College Park. And we are also welcomed by our professor, Mennella, who is a professor here in the Department of Natural Sciences at PGCC.
To continue, we are here with Dr. James Milke, who is a professor emeritus in the Department of Fire Protection Engineering in the University of Maryland, College Park, as well as Dr. Jonathan Ransom, who is the Deputy Director of the Engineering Directorate at NASA Langley Research Center. And lastly, Mr. Michael Walder, who is the Superintendent of the Radar Division in the Naval Research Laboratory. We are honored that he is also a PGCC alumnus.
Great. So just to get started on the panel, we would love to hear about your guys' personal career journeys and how you got to the position you are in now. Just for the sake of time and organization, we prefer that you guys go into the order in which we introduced you. Mr. Wilbur is not with us right now, so Mr. Felix, can you please be our starter?
Yes, absolutely. First, I would like to introduce myself. I'm Felix, and I have a BS in chemical engineering from the University of Maryland, also PG alumni. And before I want to start my conversation, thank you to all my professors and everyone here. At PG, I started my associate in engineering, it's just engineering, and I was able to tailor my major in a way that I was able to replace certain courses that would meet my needs at University of Maryland. And that's one advice I would like to, highlight in case anyone has more questions, always reach out to me. And eventually transferred to University of Maryland. And right now I work as an automation engineer for Merck Pharmaceuticals. I do have a few, I would say a few, I just want to share some tips, let me say that, to current engineering students at PG. So transitioning to UMD is not exactly like you would experience it. It's not exactly the same, right? So for example, you get a lot more homework. You do have to you do have to spend as much time, studying for classes and trying to keep up with homework and assignments. So you just have to bear that in mind as you're transferring. And of course, tips to transfer University of Maryland. If you have not heard of something like MTAP, it's a program where there are certain courses where you'd have to score, I believe, a B or higher in each course at PG before you transfer. And also, if you need more information on that, please reach out to me. Also, scholarships are always available for engineering students. You just ask the right questions, and also you could also ask, admissions or financial aid office, and they're always willing to help you out. And as far as career-wise goes, I would say preferably if you can get an internship at least your junior year. And just keep in mind, everybody's situation is different. I had an internship after I graduated. And to be honest, that also helped me a lot to get my current role as an automation engineer right now at Merck. And as usual, if you're not able to get an internship, feel free to do research. It could be as simple as just emailing. And I would say if you're at UMD, you could look for you could just search it up on Google. You'd find it, like professors at UMD that do research, and their names will pop up. Also like a brief description of what they do. If you seem interested, feel free to email them, and you guys can start working in the summer. And that's all I have to share. Thank you.
All right, Miss Ashley, can you please go next?
Hello, everyone. Can you guys hear me? Okay, just making sure. I have new headphones on, so thank you all for having me. I see a lot of familiar faces, and I'm so happy to be here. And I think just a little about myself. I'm working at L3 Harris as an electrical engineer. Particularly, I work in a pretty niche field of electrical engineering with field programmable gate arrays, or FPGAs for short. And I work in the space and sensor division. And right now I'm working on one of the United Light Launch Alliance's up and coming rocket, the Falcon 5. So it's some pretty interesting stuff that I'm working on. And let's see, am I supposed to be giving advice? I'm sorry. I forgot.
It's okay. You can just continue with your career journey to as long as
Okay. Let's see. My journey into engineering has been a very long and non-traditional one. So when I started at PGCC, I started at the bottom of the bottom in remedial courses. I was working at a small minority-owned engineering firm nearby in Lanham, Maryland, where I was exposed to engineering, and I realized, hey, engineering is a career that I'm interested in. And so at PGCC, I started off with some remedial math courses, worked my way up while I was working full-time at this engineering firm and going to school part-time. And eventually I received my associate's degree and transferred into the University of Maryland College Park. And that was not a walk in the park, I'll tell you that much. It was a culture shock. And I actually took a break from engineering for a while and pursued a certificate in Latin American and Caribbean studies. And it was probably the best decision I made for myself. I realized at that point I had overworked myself, and I had to keep it real with myself and tell myself, hey, maybe you should take this as an opportunity to step back and realign yourself. So I took that year off, and it was a lot of fun. I actually ended up doing a study abroad program with UMD, in which I got a scholarship for. And in addition to that, I went back to PGCC because I had to take a gateway course for UMD. And then I eventually transferred into the electrical engineering department. And that was during COVID. So that was not a walk in the park either. Last I mentioned that I had my daughter too, who was doing remote learning at that time as well. So it was really hectic, but I made it. I'm here now, and I'm working as an engineer now. And all of that, let's I say it was, as I mentioned, not a walk in the park, but I surrounded myself with people that made the process a lot more bearable. I found my people at the University of Maryland. I saw Felix around there as well. A lot of familiar faces from PGCC. My little sister also ended up doing electrical engineering. So we took a lot of classes together at the University of Maryland. And I would have not been able to do that had I not take that 1-year break I decided to take. And I ended up finding a community of community college students as well, from not just PGCC, but from Montgomery College, and I think another one from Anne Arundel County Community College. And I can generally say that I guess it was a walk in the park when you have the right friends, but everything else is just kind of, how do you say, you had to learn how to enjoy the process and just trust the process and realize that it'll all be over with before you know it. It's like time just flew. From COVID to now, I'm just like, where did the time go? So I think my biggest word of advice that I can give to PGCC students who are looking to transfer to a 4-year institution is just enjoy the process, trust the process, and find your people. And I know some folks are a little more introverted than others, or some are more extroverted than others, but at the end of the day, you're going to have to try to find your people wherever you are who can advocate for you and make the process more bearable. Yeah.
That is wonderful. Thank you so much for that. Professor Mennella, you are next.
Oh, hi. Yeah, well, I went to college at a different time space than you will be going. I went to college in the 60s in Washington, D.C. So there were plenty of distractions. I was a mechanical engineering major most of the time. I eventually, for some reason, I don't know, after my junior year, I transferred into English, and that was a bad mistake because they expected you to read a book a week, and I read like a page a week. So that didn't last long. So I finally, because my draft board was bugging me to graduate, I graduated in economics. Then I went to graduate school, started in economics. I didn't really like that. So I got a master's degree in math. And then after that, I went and started a PhD in physics, in which I finished all my coursework. And then I was lucky enough to get a job teaching. And so here I am. I've been teaching for 56 years, 40 of them at PG. And so that's it.
All right, next on our list is Dr. James Milke. I hope I'm saying your name right, sir.
Yes, that's correct. So thank you very much. As with a lot of us talking today, I think I am another one that had a bit of a circuitous route to where I ended up. I came out of high school and didn't know anything about engineering as a high school student, and opted for sciences instead. Physics in particular was a course I had in high school and enjoyed, and thought, all right, so I'll do physics for that, and had some interest in the space program at the time, generally anyway, or in astrophysics, I guess more specifically. But I was at Earth Science College in the early 70s. It was a very small town in outside of Philadelphia. The college had about 1,100 students in it, so smaller than the community college, and much smaller than the engineering college at Maryland. And it was a small town there, and I said I started seeing firefighters in and around from the local town. They would come onto campus. There would be fire alarms in the dorms. And I got curious as to all the gear and what was all this gear about that they had and so on. And I felt perhaps that it would be nice to give back to the community and provide some community service. I had some of my high school friends that had been drafted and were in Vietnam at this point, and I had deferral to be able to go to college, and I don't know if it was a little bit of guilt or whatever, but got involved in the fire service there. Was there a couple years, and about that, as I got into my sophomore year, at this point, I'm starting to say, what am I going to do with this physics degree? I absolutely need to have graduate degrees if I'm going to do the kind of things that of interest to me in the world of physics. Didn't particularly want to go to grad school at the time. I could teach high school physics. I didn't want to teach. I didn't think I wanted to teach high school physics anyway. So what am I going to do? And at that, I happened to go to a conference, a fire safety conference, on behalf of the fire company. It was in Philadelphia, and I picked up a brochure of this University of Maryland program in fire protection engineering, and it was just an eye opener for me to see, hey, this is a discipline that exists, and there are all sorts of jobs, and I don't have to have a graduate degree. And well, sign me up. So I finished my physics degree with some suggestions from advisors. I had go and finish your one degree, and you'll have that, and because you don't know what's going to happen when you go to Maryland. Went to Maryland and thoroughly enjoyed the program there. My first job was in the fire marshal's office in Fairfax County, Virginia. So I was the fire protection engineer for the county, and that had a wide range of experiences there. I had some encouragement from the chief fire marshal that community colleges were looking for instructors, and I said, okay, let me see, I'll look into that. And I looked into that at Northern Virginia, where I was offered to teach a course, and also taught at PG Community College, a course in hazardous materials, when there was a fire science program at the community college, and I enjoyed that. It was in Fairfax County about a year and a half. And one of my old professors, past professors from Maryland, invited me to come back and do research. And would I like to do this with him? And there might be a little bit of international travel. And I was young and single at the time. And sure, I'll do that. That sounds like a good idea. That'd be wonderful. And he said, and by the way, one of the fringe benefits, if you're a research assistant here at the university, you can take graduate classes. and pursue a graduate degree. So, okay, I'll do that. It was like signing up for health insurance and this and that. Yeah, I checked the box. I'll take some classes, and ended up with a master's degree in mechanical engineering. At that time that I got my degree, that professor that invited me to come back and do research with him, he decided to leave the university and go into the consulting engineering world. So there was a faculty position that opened up, and I was offered that position. And we go 40 years later, and last August, I retired from a full-time position at the university, having thoroughly enjoyed the research experience, the teaching experience I had there. I did go on to get a PhD in aerospace engineering because I had an interest in what happens to structures when they get exposed to fire. Served as department chair for 12 years. And as I say, thoroughly enjoyed it. As I say, I retired in August, so I'm still there part-time. So I retired more from a full-time position. I can continue part-time at the university, doing some teaching, still mentoring some students, and have also picked up a part-time engagement with a fire protection engineering consulting company called Fire and Risk Alliance that's in Rockville. So yes, I've retired, but I'm still active in the field and really enjoying retired life, because it gives me a chance to really do things that I want to do, and I get a chance to be more flexible in what I do, have a flexible schedule, but getting a chance to do what I want to do, as opposed to having someone tell me I shall now do this, and it's just a wonderful stage to be involved in. The one item I guess I would encourage you all to think about is be flexible, because as in my path, there was no vision that I would be an engineer, let alone I'd have a Ph.D. at some point, and being involved in research and that sort. That was nowhere in my vision as a 20-year-old. So to stay flexible, and don't be afraid to pursue opportunities that come up. So look forward to chatting with you further later on in the session.
Thank you so much, Doctor. We'll now be moving on to Dr. Jonathan Ransom.
Hello, everyone. It's good to have an opportunity to chat with you all again. As has been indicated, my name is Jonathan Ransom. I'm the Deputy Director for Engineering here at NASA Langley, a job I've had all of about a week, although I've served in an active capacity for about a year and a half now. My background from an undergraduate perspective is in mathematics. I have a degree in mathematics from Virginia State University, which is right down the road a bit in Petersburg, Virginia. And I had a dual degree, or at least had enough courses in computer science to have a dual degree in math and computer science, and came to NASA right out of school in a kind of odd way. I actually had a fellowship while I was in school at a school in Pittsburgh, Carnegie Mellon University. And the professor I worked with actually had a fellowship opportunity at NASA Langley. Granted, I grew up in the Hampton Roads area down here near Hampton, Virginia, but I grew up across the water. And so NASA Langley might as well been in a different country, because I didn't go through the tunnel to know that NASA Langley even existed over there. So it was kind of odd that as the professor at the time invited me over to NASA Langley, it was a whole new world for me. And it was an opportunity for me to see the great work that's going on here at the center, particularly as it relates to aerospace and space research. And so my first job was working on a parallel processing computer, which was at its infancy about that time, where we were doing some structural dynamic analysis of a simple beam on a parallel processing computer. And my boss at that time, or my boss's boss at that time, said, "Oh, great, you're a computer science junkie, so we'll eventually send you over to the computer division," which wasn't bad. But it wasn't what I wanted to do. I didn't want to be put in a box and just write computer code. I wanted to write computer code with application that would lead to, again, space exploration or lighter weight aircraft or some benefit. So I wanted to not just work in code, but I wanted to write code that made a difference. And so I decided at that time, through some guidance of a mentor, to go back to school and get an engineering degree. So I had an opportunity. We had a pretty strong training program here at the center. I had an opportunity to go to Old Dominion University to start a graduate program. Unfortunately, or fortunately, in order to get the foundation for taking those graduate courses, I had an opportunity to take about 30 hours of undergraduate courses in statics, dynamics, and those things that are the precursor to becoming a good engineer. And so I had an opportunity to do that. Eventually got my master's degree in engineering mechanics, and then wanted to come back to work and get some things done. I'd spent a fair amount of time outside of the workplace and wanted to, develop my career a little bit more. So I spent some more time here and got some skills that would help me to progress my career. And then I got an itch again and said, hey, well, maybe I want to get a Ph.D. So I went back to school and acquired a Ph.D. in aerospace engineering. I guess I would also comment that at the time I got my master's degree, I had my first son, and my wife had our first son. And so there certainly were a lot of nights where I could appreciate some of the questions that might be related to work-life balance. It was very difficult to balance life when work-life merged on a 24/7 basis. And then when I got my PhD, I had my second son. So I don't know, maybe I'm like someone in the Navy. When I go to school, I have a baby. I'm not sure. But nonetheless, it was an opportunity for me to strengthen my skills with regards to time management as well. And so as I've been in NASA here for multiple decades, I've had an opportunity to develop my career and perform research in an area of detailed stress analysis and structural analysis, as well as develop my leadership skills as a branch head and as a chief engineer that monitored the work and maintained technical excellence of the products that were coming out of the organization, and then eventually in leadership positions. So I believe that I made a name for myself in doing research, independent research myself, and as a leader to monitor the work that's being done by others, and also to shape their careers so they could do independent research and have an impact on our nation and on NASA's future. And so I would say any advice that I would give would be, again, don't let yourself be put in a box. Get as much as you can get, be as multifaceted as you can be, and don't let anybody tell you what you can or cannot do. That would be my advice, and I look forward to any additional questions that you might have.
Thank you so much. Now we'll move on to Mr. Michael Walder.
Hi, I'm Mike Walder. I am the superintendent here at the Naval Research Lab Radar Division. I have been here at the Naval Research Lab since 1985, after graduating from the University of Maryland with an electrical engineering degree. I am from PG County. I grew up in Temple Hills, Hillcrest Heights area, went to Potomac High School, and I was a pretty lazy high school student. So when I knew I wanted to do something technical, and I started the pre-engineering classes at University of Maryland, at PG, ran into calculus and said, oh, this is too hard for me. I could never do it. So I diverted and got a degree in geography, which sort of touches on one of the double major questions. But I don't consider that to be wasted time from an engineering career, because geography taught me how to write. As hard as I had to work to learn calculus and all the more challenging STEM classes, having good writing professors and coaches and teachers and mentors has been crucial to my success in my career as an engineer. So focus on the writing. But I went through PG for 2 years, then went to University of Maryland and got my geography degree. And towards the end, I really still had the itch for engineering. I took a physics class, and I liked it. And I finally found that if I worked at it, I could do it. So I talked my parents into letting me continue back in school, and I returned to PG and pretty much blew through all the freshman and sophomore courses that I needed to take in about a year, and then went back to University of Maryland and got my bachelor's in EE. And best decision I ever made was going back and getting it, because that's truly where my passion was. While I enjoyed geography and learning about the world and how the world works and people behave, my passion is more towards the technology. My typical workday when I was fresh into the work was really I was a protege to more senior engineers, where I would design circuits, collect radar data. We'd operate radars, and I had never really knew what a radar was before I started my first job. And I think, like a lot of people I've observed over my career, that first job is crucial, and we often become quite passionate about that first job in the field if you have the general interest. So I certainly didn't start out saying I want to work in radar, but once I started working it and spent time on it, I found I really did enjoy it, and was quite curious about the phenomena and the systems that were developed to exploit that phenomena. Just as an aside, for those of you who probably, like me, when I was a student, wouldn't have a clue what a radar is, it's a radio system. So your cell phone could be used as a radar in some circumstances, and in fact, in some surreptitious circumstances, people do use them as radars. But it's a radio that's optimized to detect signals that are reflected off the surface of an object, and that object can be aircraft, ships, the ground. I remember as a geography student learning about synthetic aperture radars, which look at the surface and develop a map of the surface. And I think I could never understand that. Well, here I am doing it. So the, as far as my journey as a student, though, the most important lessons that it took me a while to learn was I can do it even if it's hard, but I have to choose to do it. And I may have to work a little harder to do it than some, at least in some areas, but there are other things that I could do that were quite easy for me. So don't be afraid of doing something hard. And if you stumble, pick yourself up, brush yourself off, and try it again. It's already been mentioned to be flexible. One of the things that I remember struggling my first time through STEM classes was trying to approach problems in a rote fashion and memorize the steps rather than focusing on the concepts. The key for me was forget about memorizing, focus on the learning, and try to relate it to something in the real world. And my favorite class as an EE major was physics. I think just about everybody has mentioned that. It helped me relate to the real world and understand how everything operates from the macro scale to the micro scale and to the quantum scale. It's physics is really the foundation for everything engineers do. For me, the most challenging course was calculus. It took me a while to adapt to my perspective to not one of rote memorization, as I've already said. My daily work today is not engineering at all. I'm a supervisor. I work through others. I accomplish far more than I ever could as an individual, but my fingerprints are not on the work directly. It's all indirectly. I help people achieve their program goals and their career goals through what I do. If I do my job well, they're able to do their job well. For me, the choice for engineering, while it took me a while to get here, I wouldn't look back at all and change a thing. I would highly encourage all of you to continue with your pursuit of your degrees if it's truly something that's a passion for you. And I'll end it there.
All right, thank you guys. Thank you. Thank you to our wonderful panelists. You guys have truly explained your wonderful career journeys, and we are, I'm so sorry, and we are so excited to talk with you. So our first question from Victor is, do you have any strategies for learning? And anyone can answer.
I can attest to that as far as strategies to learning. I'm very early on into my electrical engineering career. I'm coming up to my 1-year mark in May. And honestly, I think I'm no expert, I can say that much, but one of my mentors has always emphasized to me, you know, when I'm going through my imposter syndrome breakdown, you know, I reach out to my mentor. And I think something that she really resonated with me was she told me, you know, sometimes you're hired as an engineer for your capability to learn. And I kind of took that and ran with it. And I'm on the job now, constantly learning new things and all this system design stuff. And it can feel like you're kind of drinking from the fire hose. My manager kind of likes to make that reference. And I realized that as far as learning goes, you really have to, everybody has different learning styles, you know, you just really gotta find that. And I find that the best way for me to learn personally is kind of like take a step back, read what I can, and then I've realized that, okay, if it's not making sense, I take a break, I go read something, I go for a walk, or, you know, maybe I go for a coffee break, I come back and get right back to it. And then if it gets to the point where I get stuck, I just reach out to one of the more senior engineers or my manager and just kind of keep repeating that. And I know it sounds very formulaic, but it's a strategy that really does work. It's kind of like self-study and going back to the drawing board, coming back with questions. I found that that has always helped. But as I mentioned, everybody has different learning styles. So for others, it could be like they might need help straight off the bat. Like maybe you may need help with, okay, can you point me to what I should be looking at? And a little more like things like that. So it varies. But I think that's the best way for me to learn.
Yeah, I would advise students to get into study groups because in my experience, study group people always get the highest grades.
For me, it came to, I always found that I did far better when I went to class prepared, which meant reading ahead. I felt far more ready to absorb the wisdom of the instructor, participate in the class. Now that you're prepared, you can ask more informed questions and better understand the difficult points of the subject. And then afterwards, practice, do the homework, do more than the basic homework that's assigned. Do as many as you have time to do. So I just called it the 3 Ps, you know, preparation, participation, and practice.
I could weigh in. I'd want to second Professor Mennella's idea of study groups. I think one of the best ways to learn, at least for me, is when I have to explain something to somebody else. And if you're in a study group and have to explain how you approached a problem, it helps reinforce the methodology that you use and your understanding of it, or identify where the holes are, as the case may be. And either one of those is going to be really valuable going forward.
Yeah.
Amazing, amazing. Thank you all very much. That was very helpful.
One thing I want to follow up with, I'm sorry for interrupting. I was on mute when I was talking earlier.
Go ahead, sir.
I'd
Sorry.
add is also to consider being a tutor. That also helps you to learn as you tutor someone else. And that tutoring could be at the community college or it could be high school, because going over fundamentals with someone else helps you to be more fundamentally sound. Another point that I would add is with regards to strategies for learning is don't stop. Don't ever think that you've learned everything you need to learn, and continually seek to learn from others that you work with, or from mentors, or from folks that, again, you might be tutoring or helping to learn themselves. So don't ever think that you've arrived, and continue to strive to learn as much as you can in everything.
Thank you very much, sir. That was very good. So I have a question for Mr. Felix Forcho. Earlier, when you were introducing yourself, you said we could reach out to you. While we wait on more people to post their questions in the chat, can you tell us how best we could reach out to you via email or phone number, whichever way you want us to reach out to you?
Sure, preferably email. And that's, if you have any specific questions with regards to, anything, honestly, with transferring, career-wise, if you would like my advice, sure. Yeah. And I
What's
can
your
put it
email?
on the chat.
Okay. Thank you very much, sir.
Sure.
So one person in the chat asked if it is advisable for them to become a cybersecurity engineer. That question goes to anybody.
If you try to make some money, then yeah, go for it.
Cybersecurity, to me, is pervasive among all of the disciplines. And so it definitely is a growth area, growing here at Langley, growing across the government agency as well. So certainly an area well worth spending time in if that's your passion.
All right. Sorry, I just wanted to pop in and say, if you guys have any questions to make sure that we don't miss, please ask them inside of the Q&A so that we can directly go to your question.
That's good. Thank you, Adana. Thank you also for answering the cybersecurity questions. And there's another question in the chat about computer science and computer engineering. What difference do you see? Do you think those two majors differ, or they end up meeting somewhere? Do you think is meaningful to switch from a computer science major to a computer engineering major? Please, what are your take on those questions?
I can answer that question. So as a recent graduate from the electrical engineering and computer engineering department at the University of Maryland, my best advice would be to you should really ask yourself, because a lot of computer engineering students that did graduate from the EECE department just end up going into the industry as a pure software engineer. And then they sometimes switch from computer science to computer engineer and not really take into consideration the electrical engineering part of computer engineering, which involves a lot of classes in like hardware, computer architecture, and things of that nature that you may never see again in your lifetime as a software engineer. So you really have to take that into consideration. Well, what do you want to do in the industry afterwards? Now, if you don't know what you want to do in the industry afterwards, then if you want that flexibility to where, okay, I'm not sure if I really want to do software, or do I want to do hardware, do I want to do both? Then in there, I would recommend you doing computer engineering. Me personally, I started off pursuing computer engineering, but then I realized I took a Java course at the University of Maryland, and I'm like, nah, it's not for me. I like more like circuits and hardware and things like that. So I ended up making that transition from computer engineering to just pure electrical engineering. And then that's that also applies vice versa. As I mentioned, there are some students who just start as computer engineering and realize they don't like the electrical engineering stuff and just end up doing pure computer science. So you should really ask yourself these questions before you decide to pursue that.
Thank you so much for that advice. For all of our panelists today, what would be a typical workday for you?
Well, my typical workday is I get up about 7:30, 8 o'clock in the morning and then watch the news, watch a movie, and then around noon start getting myself ready to go teach. And the thing is, I'm kind of fortunate in that I'm in 3 different departments: science, engineering, and math. And I get to teach a lot of different things, which suits my personality because I always wanted to learn as much as I could about everything. I mean, just recently I read about a black hole that swallowed a neutron star that was 600 or 900 million light years away. Now, that's an incredible distance. That's about 6% of the way to the edge of the universe. I like stuff like that. And when I read about it, I share it with my students. And that's my typical workday.
Thank you, sir. So I have one question about mechanical engineering, right? I know it's there's a typical thing out there about being a jack of all trades, at the same time being the best major out there. But what's the advice on a student who wants to study mechanical engineering? Do you think they should actually do that or go for something more specific?
Mechanical engineering is the mother of all engineerings. If you're a mechanical engineer, you got your finger in everything, and you can be hired even as a physicist. So yeah, my advice is go for it. Go for mechanical engineering.
Thank you, Professor Mennella.
I'll go ahead and offer a different point of view here, I guess. I mean, nothing wrong with mechanical engineering. My master's degree is in mechanical engineering. And it is a very, very broad field. Where you have passions in a specific area, though, pursue those. Whether that's in maybe a civil engineering or chemical engineering, EE, fire protection, materials, right? So, find an area that you can be passionate about. And because that's where you're going to be most successful, as opposed to going through a degree program because somebody says you have to, and that's the only thing that, right? You need to have a passion. You need, and especially in an engineering program, as you're seeing, even in the first 2 years of courses you're taking at PG, you need to have a passion, need to have a dedication if you're going to succeed, and you want to pursue where your passion is. I think there are wonderful job opportunities throughout the engineering field. For the graduates from College Park, the job placement is very, very good for all engineers at this point. So it's a great market to be studying engineering, great time to be studying engineering. Now I have some biases to maybe where there's a better job market, but that's, but anyway, but I'm sure we'd have 6 different opinions of that here. Yeah, but maybe do some research, right? See what the various disciplines do. And I mean, mechanical, yeah, you'll get lots of opportunities, a wide variety of opportunities without question. So
I agree 100% with what you said. I agree 100%. Go for it.
Yeah, I actually started out wanting to be a mechanical engineer, but I saw mechanical engineering as a 18-year-old as a car. I didn't recognize all the other parts of mechanical engineering, and from structures to thermal management, you name it. Again, as already has been said, it's what gets you motivated. There are so many, in addition to the broad specialties in engineering, there's subspecialties within each type. And many of them are combinations of the two. Servo mechanisms, the electrical control of mechanical structures, is a particularly important area today. So, but in the end, if what do you find yourself noticing as you go about your daily activities? Do you notice things in the world that capture your interest and make you wonder why it does what it does, why it doesn't break? If you find yourself thinking about those types of things, then you'd probably make a good mechanical or civil engineer. So, think about, a little bit of in the news, the truss bridge that just collapsed in Baltimore Harbor. I remember well going through my statics class and analyzing trusses, and that's a direct application of that class. So again, there are many aspects of mechanical engineering, and until you get into it, you really won't know. So ask other practicing mechanical engineers.
Will anyone else like to give their input to the question? All right. Professor Thakor in the chat asked, what were some of your biggest challenges during your journey and how did you overcome them?
Well, my biggest challenge was going to class. I went to school back in the 60s in Washington, D.C., and there were just too many distractions. That's why I took some of my classes over again. So that was my biggest challenge, making it to class.
I would agree with that for me as well, particularly in undergraduate school. There are often so many other things to do other than study, other than go to class, other than go to the professor's office to ask the question that you were afraid to ask while you're in class. In graduate school, my biggest challenge was that transition from being a mathematician to being an engineer. Having some of the strong mathematical foundations, but not necessarily having the strong engineering foundation. And courses like thermodynamics, my biggest challenge. Could hardly spell thermodynamics when I went to school, and I'm still not sure I can spell it now.
No, you know what? That was one of my most challenging courses also. And in fact, my thermo professor had to put up a display, and he took the worst test and the best test. And I was both of them. So
Just to add on top of that, I would say when transferring, you're essentially done with like most of your sophomore year, right? So you're going into your junior year where it's like considered the hardest, year of college, right? So you're essentially like taking mostly like engineering courses. And to be honest, just transferring into just taking engineering courses, let's say 4 or 5, you're a full-time student, it's sometimes everyone's different, but sometimes it was hard, grasping the concepts and everything. So to overcome that, honestly, like Dr. Rocco said before, have study groups. Like for me, it was better and easier to like understand from my classmates versus like, the professor just, displaying slides and then just like talking about it, so I would say that.
I agree with you 100%.
I guess I can kind of piggyback off to what Felix mentioned. I faced a lot of adversity throughout my undergraduate years as a single mom and at some point working full time as well by pursuing my associate's degree. And one of the ways that I did overcome some of these challenges, as I mentioned before, is finding my peoples. And I found my peoples through study groups like Professor Rocco had mentioned. And, you know, till this day, we still remain close friends. Those friends that I made at the University of Maryland. As a matter of fact, we have a trip planned to Vermont. We're leaving tomorrow to go watch the solar eclipse. And I think the best way we can overcome adversity, as I mentioned before, is surrounding yourself with good people so you could have a good walk in the park. Engineering is not easy, it's hard, but having the right people can make it more bearable.
I'm just going to repeat what most everyone else said. The lesson I learned, I've given was a saying that was on the physics class, the bulletin board in the physics classroom at PG. A quote by Thomas Henry Huxley. And to paraphrase, it's, you know, the most important part of education is making yourself do the things you need to do when you need to do it. And it's a hard lesson to learn, and however important it is, it's one we have to keep relearning. And I wish I could remember the physics instructor I had at PG that had it there, because he had quite an influence on me as I grew. And it's an important lesson I still carry with me, and I have it on my other monitor right now.
Thank you so much for all of that. Thank you all. Does anybody want to say anything? Am I interrupting someone? Okay. Just as a backup question to the question that was answered, specifically, is there any favorite or challenging, actually favorite and challenging courses that you had during your undergrad or maybe graduate school that you would like to share? And how did you address those challenges? Did you ever overcome them, or you just graduated that way?
Well, when I was in graduate school in physics, there was a problem I was working on during spring break. And I remember my apartment was full of balled up pieces of paper where I failed to answer the question. I couldn't do it, but I kept trying. And it was the last night at 4 o'clock in the morning, I woke up and I had the answer. So you never stop trying. It keeps cooking in your brain and you'll eventually get it.
Thank you, Professor.
Kind of to piggyback off that, the hardest course I ever took was a senior math level course at the University of Maryland. It was a partial differential equation class. That class was a killer, but fortunately, I had wonderful professors like I see Professor Rocco and Professor Mertova. I took linear algebra with her at some point. And something that always stuck with me was math is not as hard as you think. It's funny because I think I remember a quote Professor Rocco has said at some point is that, oh, you know, someone has already done the hard part for you. So you just got to go and figure it out, right? So that has always stuck with me. And I realized like, there's actually only so many ways we can analytically solve partial differential equations. And it can become very systematic. And at some point you can solve them numerically. But then I realized, you know, maybe it's not as hard as I thought. And I've always approached these very difficult courses with that mindset. Like, if they can do it, I can do it type thing. And that class was very difficult. It was very, very difficult. I would spend, as Professor Rocco mentioned, on one problem, probably like the whole spring break. And then at the very last minute, it just pops up. And so the way I've really overcame these difficult courses is by just remaining an open-mindedness to it and also a positive attitude. A positive attitude can take you a long way. You just have to convince yourself that it's not that hard. I promise you. Just do it. Just do it. That's it. That's sometimes all you got to do. So I ended up finishing up the course, and that course has helped me throughout the entirety of my undergraduate career until this day in my professional career as well, because partial differential equations is everywhere. Like, I saw it in my electromagnetism courses. I saw it in my device physics courses and my quantum physics courses. It's everywhere. And I realized if I can do it in this partial differential equation class, then I can do it in the rest of my courses too. So the best word of advice I can give to you is stay positive. Just stay positive. Yeah.
One thing that I might add is I mentioned that I had a internship or fellowship out at Carnegie Mellon University when I was an undergraduate student. I also had an opportunity to have an internship at Fermi National Accelerator Laboratory outside of Chicago in Illinois. And I was again, mathematics major with a computer science background, and I was invited out there to develop a piece of code that would process all the data from the tunnel that they'd been taking on, and I'm showing my age, magnetic tape, and converted into digital on the computer. And I was away from home for the first time, distraught that it wasn't working. The mentor that I was working with was off on vacation, and I was frazzled. So I actually had an opportunity to talk to one of the physics professors was actually out there doing physics work, and I talked with him, and he got me centered. And so I guess my challenge was getting over that fear, kind of in line with what Ashley has talked about, and getting centered and knowing that I could overcome it, and just setting in my mind that I could as opposed to I couldn't. And so it actually turned out to be a very valuable experience for me.
Thank you all so much. Has everyone chipped in, or is anybody else trying to say something? Okay, thank you. I will take that as a no. And there's one more question that I have. This actually goes to everybody. So the question is, what has been not what has been actually, because I know it might be a lot. What has some of your proudest moments in your career, just coming from undergrad to where you are right now? What are some of your proudest moments?
I'll jump in. So for me, it's seeing the projects that I contributed to result in new capabilities for the Navy. I've been fortunate in my career to work on projects where I had a key role that resulted in security systems for naval bases and in 2 radars that are now on Navy ships. Just seeing your work result in national capabilities, whether you had a small part or a more substantial part, just being part of the team and contributing. So there's a great satisfaction for me to go see a Navy ship with a radar on top that I worked on as a young person. And I point to my kids and say, I worked on that. And they go, so what? So it means a lot to me. So results is in short, what gives me pleasure.
I would like to add, I didn't get to mention my day-to-day role as an automation engineer. So at Merck Pharmaceutical, I specialize in HPV vaccine production. I support that building. So essentially, as an automation, it's just making sure, production is continuous, right? even though I joined last year, I was able to help, reduce downtime to scale vaccine production from 100 to 120 batches, even though, I was still like a, new engineer or whatever. But also as an automation engineer, you essentially help with, software updates. You help with troubleshooting. So we're like the first point of contact, if the batch goes into hole, or sometimes they call it the train or batch, however you want to call it, goes into hole, you're like first point of contact, like, hey, could you troubleshoot what's going on? So you just log in, go check where it's actively running in the code, see what's being held up, and you essentially advise like operations team, like, hey, this is what's going on, and here's like the path forward. But proudest moment is helping scale vaccine production.
I can offer a few thoughts if you like. I mean, the one item to reinforce, I think the first comment that was made was that Mike Walder made. It was the opportunity to see the results of your work, and that's engineering in general, and that's one of the distinctions between engineering and the sciences. I think that you actually get to see this structure go on up and look at it and say, I had a part in that. Or if you were involved in some research, for example, you see the implementation of that research in the practice of engineering, maybe a little different style that the engineering is practiced, different calculation method that's available for design engineers and such. And just being able to see the fruits of your labor and feel appreciated for that is really, really endearing, and makes you feel good when you go home on a Friday evening thinking about what you accomplished in the last week.
I can attest to that as well. From my personal perspective, my proudest moment was developing a computational approach for detailed stress analysis that was implemented in the largest structural analysis code in the world. And so, again, the fruits of my labor, seeing it brought out and made available to the world was certainly a high point in my career. I would also say that from my perspective now, it is watching others have their high points in their career. Watching others that are now putting instruments on the moon is something that I view as a high point of my career, because I see the joy in their eyes when they, again, do something as impactful as that.
Thank you, sir. Professor Mennella, do you want to give us a little bit of some of your accomplishments that you're actually very proud of, and Miss Henriquez as well?
Listen, I guess I'm self-observant. I'm proud of everything I do. I just can't help myself, because I think of myself as the greatest and the smartest and the brightest person on earth. No, I'm just kidding. I'm just kidding. I'm amazed when I can do anything, really. That's to me, I mean, the best thing that can happen to me is when a student asks a question and I'm able to answer it. That's, to me, that's my whole life.
That's good, Professor. Miss Ashley, do you want to?
Yeah. Just to kind of piggyback off what everybody else has mentioned about just being able to see the fruits of your labor. Well, as I mentioned, I'm still very early into my electrical engineering career, but I am working on a rocket, doing the hardware design for the avionics that's going to go on the United Launch Alliance, newer rockets, I think the Vulcan, and we're doing the controls on that. And L3 Harris actually flew me out to Cincinnati, which is to work in a lab and I physically got to see some of the stuff that we're working on, and I'm just thinking about like, wow, oh my goodness, I'm working on this thing that's going to space, and it's just unbelievable. And I'm not very humble at sometimes. I like to brag about it to like my friends, and I was telling my mom the other day, oh my goodness, mom, you're not going to believe this, but I'm working on a rocket. And she's like, what? Oh my God. It may seem small at first, but it's really a huge milestone. Being to say that my first job as an electrical engineer is working as something as impactful as this rocket that is designated to be ULA's newer rocket and stuff like that. So I think there's just something very satisfying in that, and just being able to see the fruits of your labor, as I believe Mike mentioned at some point. So I think, yeah, I'm proud to say that I'm working on a rocket.
That's good. We can't wait to be proud too one day, right? Thank you all so much. I'll hand over to Dana.
Thank you. Within the chat, Matthew asked, how can I gain engineering experience before my first job or internship? Oh, I see Dr. Ransom has answered within the chat, but if any of the panelists have any input that they would like to give, please do.
I'll jump in here a little bit. I think that the role of an internship is largely to get experience and to see what you like. And don't be afraid to go to different places at different summers. You don't have to go to the same place every summer, same type of organization every summer. This is the chance to put your toe in the water and see what you like, see what kind of outfits and job responsibilities you don't like. And so I wouldn't get too hung up on I've got to get a bunch of experience before I can do an internship, because that's the purpose of the internship.
I think to build on that, certainly though, your hobbies can give you that exposure. If you like to build circuits or build, for me, even though I at a time considered the time I spent working on cars, building knot rods, wasted, it actually gave me an extremely strong foundation in mechanical engineering. So I think your hobbies are key, and those hobbies can be programming, as software as well as hardware. So and those hobbies, what you choose to do in your hobbies are probably good indicators for which specialty you might want to go into as an engineer.
Would anyone else like to give their input?
One comment in line with what has been said is, again, gain experience in which you have a passion. It took me off guard at one point, but interview the interviewer to determine if whatever organization that you are considering is a good fit for you. So that would also be a piece of advice that I would offer.
Thank you. Professor Mennella, Mr. Felix, Ms. Ashley, do you guys have anything to comment on?
No, I agree that with Dr. Milke, who said that internship is how you gain the experience. I think there's very little opportunity to get experience in engineering other than with an internship.
Yeah, I mean, everyone is right. You will eventually get some hands-on experience. For example, at UMD, they have like a chemical engineering lab, and you do have to take a class for that as required. And you do learn or I guess you get the chance to apply like your, engineering concepts, hands-on. So, honestly, other than that, your best shot is just trying to do research over the summer or something. But yeah, but an internship is the purpose of, getting experience.
And Felix, thank you for that. I mean, you've just jogged my mind here a little bit, and one of, as you said, pursue opportunities to do some research as you move on. And there I suspect there are opportunities at PG, but certainly if you come to College Park or go to any 4-year school subsequently, there'll be research opportunities that faculty will make mention of perhaps in a class. And hey, anybody who wants to do this or wants to be involved in this competition, come and be part of our group. And don't be afraid to raise your hand and volunteer for those kind of things, or maybe get a few bucks. In some of the research positions may include some modest compensation, but don't be afraid to step up and pursue those opportunities, or go straight to the faculty member that's teaching a class and just said, hey, you'd love to get involved in any research you're doing, even if they're not mentioning this, and they might have some things that to include you at least as a volunteer in the lab, if not again to give you maybe a few dollars to help pay some bills. So
yeah, to pile on that aspect, that's certainly, I worked as a student aide in a professor's lab at Maryland while I was there, so that was a great pre-internship experience for me. So talk to your professors and instructors. I was fortunate enough that the instructor in my electromagnetics class announced he was looking for somebody. After class, I went up there. I was the only one that came up, so I got the job. So in regards to internships, so you're in a target-rich environment in the DC area, but the target is dominated, the opportunities are dominated by government. And you just have to recognize it takes longer for the government to hire. So you have to plan a little further in advance, whether it's at NASA or for the Navy or any other government agency. If you want to intern for the government, you really want to start that process at the New Year's timeframe, just because it takes a while for the government to unfortunately get you on board. So I hope that's not the case in the private sector, but certainly, unfortunately, it's the case in the government. And if you don't have a Handshake account, Handshake is a fantastic program that's on the web. Most university career centers use it. I'd strongly encourage the students to mine that for opportunities.
Ms. Ashley, before we continue, do you have anything you want to comment on?
Yes, I also resonate with my first internship experience was actually a research experience. And that was because Professor Hutland at PGCC was asking students, hey, are you interested in maybe doing some computational chemistry? Remind you, at that point, I was thinking about computer engineering. But anywho, long story short, I ended up working that summer at Dr. Gutierrez's lab doing some computational chemistry work. And that just really opened a whole new world to me. And from there, I just continued picking up research internships for summers. And, there were paid internships, fortunately, as well. And the research experience that I've gained from those internships were invaluable. I was able to land other internships in the private sector as well because of those previous research experiences. And well, I don't want to say they're necessarily private sector, but they were like not research related internships. So I would definitely recommend just stay open-minded, and if an opportunity pops up, seize it. It can take you a long way, or you never know where it could take you.
Thank you so much. Now that we have been now that we have learned more about each other, I would like to know if you could switch careers with anyone within today's panel, who would it be and why?
I'll probably say Mike's. I like the radars. I think it's pretty cool. I'm interested in like IR detectors and stuff like that. So I'll probably switch with Mike for a day. Well, I think now you do more director stuff, but even then, you know, still pretty neat.
Well, thank you. I actually worked on programmable gate arrays, but you had to lay metal when I worked on them. I think I'd change jobs with any of the panel. Everybody has a unique aspect and an interesting aspect. I always think of retiring and teaching. My choice of jobs when I was coming out of school was for the Navy and for NASA. And I got to admit, I had a hard time not going with NASA. So, you know, and I just sat through a medical malpractice suit. I just did my jury duty, finished it yesterday, and I'm sitting there thinking I'd certainly like to become a bioengineer. So I think, you know, the more time you spend in your career, the more you get exposed to, the more you see that fascinates you. And I'd probably trade places with any one of the panel.
Look, I don't think I want to trade places with any of them. They all work too hard. I mean, come on.
Those are all grammatically correct or politically correct statements, but I would say my father was a physics professor at Norfolk State for 45 years, and it was always stated that that was my lot in life. So I would say I would change jobs with Professor Mennella or Miss Henriquez there, because she's early in her career, as is Felix, and I see both of their eyes gleam as I'm nearing the end of my career. I would love to get that gleam back a little bit.
I have to say that the reason that I'm struggling here with who I would change with is I've thoroughly enjoyed the career that I had in education, and with Professor Mennella, you know, with along with him, my schedule is somewhat similar in going in to teach, or was before going into the semi-retired state. But going in to teach, doing research that, and I was able to teach the classes largely that I wanted to teach. There would be some discussion with the department chair at the time as to, you know, separating out the classes to teach and so on, but I usually got my choice. I always did the research I wanted to do. No one came to me to say, you have to do this research project. I didn't have an engineering supervisor telling me, all right, Ms. Henriquez, this is what you have to do. This is the project you're going to have this week. I was able to choose what I wanted to do in a particular week, or particular year for that matter. So it was something that and one of the reasons I'm really a very strong supporter of anyone thinking, hey, I might want to go into academia, because it's a wonderful career path. I would say that just with the liberties you have, the flexibility you have, I don't think there's anything like it. And with due respect to the others in the group that are not academics yet, though Jonathan, you know, maybe that's right there for you, or Mike, but and Ashley, it's just around the corner for you from you, I'm sure. So and Felix, sorry, I cut you out there. But yeah, I would struggle with what other position I would want otherwise. So sorry, and I can't be more. I can't play along a little better with the question, I guess.
That's perfectly fine. Thank you. Mr. Felix, would you have anything to comment on? Anyone who you would hope to switch careers with?
I think it's a hard one. So I would side with Mike, because I have a background in chemical engineering, right? So today we're troubleshooting why our water pumps would not, supply, water to our, facility, right, for processing. And whenever there's anything to troubleshoot, like, or, automation, hey, can you help us fix this? And it's more of like a mechanical issue, right? Mechanical and electrical, and I have like zero background. And I mean, you're expected to just, fix it, right? So you communicate with, maintenance department that, they have like mechanical engineers, electrical engineers, and, other people there. So, we're just talking and they're talking about a bunch of stuff, which, I have no, experience with, right? So it's just interesting to learn about. That's how you gain experience, like, just troubleshooting with other teams as well, right? So yeah, it's a tough question. Yeah. So I would switch positions with anyone, essentially. Yeah, that's what I'm saying.
Thank you so much for answering. Just so that we can, just so we be sure that all information you want to give out to our students is given, is there anyone who would like to present anything briefly before we come to a close on our session? Anyone? I believe Dr. Ransom, did you
Well,
have?
if there's interest, we can throw up that video, but it depends on how much. I think it's about 3 or 4 minutes. So if we don't have time, I can certainly just show the QR codes,
Okay.
whatever is beneficial to the group.
We have ample time.
Decide.
Yes.
Yeah, excuse me, we have time and that the video is actually 1 minute long, so you're fine.
Okay.
You're perfectly fine.
Okay.
Perfect.
Do you want me to show up the video right now?
I think it would be appropriate.
Perfect, thank you.
Sarah, sorry for interrupting. There's no sound.
My apologies, I will reshare in a second.
No problem.
While we wait for them, we can ask another question. So there are conceptions about if you study engineering, it is very likely for you, not even likely, like there's definitely one big good life out there waiting for you. Is this really true or is it a misconception? Also, does it happen that most people after their undergrad, or let's say undergrad, they get a job instantly, or do people have to wait 2 years, 3 years, 5 years? Is it so competitive, or is there like a definite, yes, when you're done, you study engineering, you're good? And yeah, this question goes to anybody.
I feel like me pursuing a degree or career in engineering was the best decision I've ever made in my life because of the benefits that come with it. You're a working professional and you're making a decent salary compared to the average salary here in the United States. And that's something that you can just never, well, at least it's a more competitive salary compared to other professions in the United States. And you can never go wrong with that. And at the end of the day, I am satisfied with what I'm doing. I love what I do, and I'm making money in the process. So I'm not complaining. But I think it's a good career path, and it varies from person to person, and the job as well. Some folks come into engineering and it's not what they expected it to be, and that's perfectly fine. You don't have to work as a traditional engineer, but because you have that engineering technical background, you could pretty much work anywhere where you want to work. Like I know people who don't necessarily go out working in a more technical engineering field. They work like as a patent engineer. They work for patent offices, things of that nature. And there's some folks who they have that engineering background and they do like data science and things of that nature. So don't restrict yourself to just engineering traditional job roles. because you have that technical critical thinking skills that applies to any job. And as far as finding a job straight out of undergrad, this is something that I've realized the students that I went to school with who ended up getting a career or a job straight out of college is because they had internship experiences. So my recommendation to students is it's never too early to start looking for some sort of job experience, any job experience. And I'm not saying don't settle either, but it's recommended for you to start looking into jobs or technical roles as early as, it's never too early. You can do your first semester as an engineer. So if you're looking to find something straight out of it, like out of undergrad, my recommendation to you, the likelihood of you finding a job straight out of undergrad depends on you've had internships or not. So I think that's something that students should take into consideration. Yeah.
Thank you so much, Miss Ashley. That was very helpful. Does anybody want to touch on that question? Okay. So moving forward, oh, sorry, you can go ahead, Mr. Forcho.
I was going to say, I think Ashley has touched, on everything. Just doing your best to get an internship. I mean, then again, if you don't have an internship, it's not the end of the world. Like, one thing for sure is, as a new grad, you will get trained on the job. And to me, as an automation, to be honest with you, everything I've learned on the job, I've never learned at school. Like, I have the, technical background and everything, but as far as what I do daily, I never learned it at school. So don't be scared. Just know you will also be trained. But then again, it's also good to, have some experience if you can.
Yeah, I think having that internship certainly makes it easier to find a job if it's not with the folks you interned with, certainly with others. But it's not crucial. I didn't have an internship. I remember when I graduated, I had good grades and I didn't have a job coming out of school, and friends, classmates of mine who didn't have quite as good grades, but an internship, walked right into a job. So it sort of greases your path into a career. So it's certainly good. It's good to have. And whether you end up as a practicing engineer or use your engineering education to carry you into other careers. I have two uncles who had engineering degrees who went into business and were quite successful, made far more money in business world, in their business roles, than they probably would have in engineering. So it's great career preparation, whether you stay in the field or move on to other uses of your education.
I can pitch in here, I think, a little bit as well. Just internships, as we've said, that they can be very, very useful to you. I mean, for the companies in the fire protection world, that basically any student that wants an internship can have one. So that all of our rising seniors will have internships. Probably have had multiple offers for what internship they take. The rising juniors largely do as well. So it begs the question that if you do not have an internship by the time you're graduating, the prospective employers start saying, why not? Why didn't you have an internship when everybody else did that you were part of, that was part of your cohort? So some of it may be discipline specific as to and what's the market like in that particular field for internships. But it's been said that the internships help you understand what kind of things you want to get involved in, or again, if the internship's maybe not your best experience, that's important too, because it says I don't want to do that one. I want to do this thing over here instead. But there's tremendous learning, as Felix has brought up. I mean, there's a tremendous amount that can be. There's only so much we can do in a 3-credit course to teach, or in a 4-year program. that you're going to learn a tremendous amount of things once you get out into that marketplace, and that includes the internship, let alone your first couple of years on the job. So yeah, but you want to put yourself out there. Put yourself out there. I mean, you're studying this engineering potentially, or this engineering field. Presumably, they get a job at some point. So why not start exploring that as soon as you can, as soon as the opportunities exist, and go with that. And I mean, the first job is, I had a good friend of mine who is the president of a consulting engineering company that has an international footprint. And he would come back to campus and say, to our students, the most important thing about your first job is that you get one. After that, you're not signing for a career to work with that particular company, but you're getting some experience. You're getting started. You're getting that experience to becoming a professional engineer, if that's important for your discipline. For understanding maybe what grad school programs you want to get started in, the variety of things like this as to what helping you define your career path. So it's just getting that first job allows you to put your toe in the water, and that first job really that same sentiment could be applied to that first internship that you have. And there's absolutely, during the summer months, maybe you don't take any classes, or you take a reduced number of classes. It gives you a lot of free time. Well, what are you going to do with that free time, right? Rather than be a lifeguard at the local pool, get a job in an engineering company. And yes, it's a little late, as Mike said, to be looking at positions in the federal government now. A lot of the private sector, there are still lots of opportunities. The private sector can turn on a dime in a lot of cases for a lot of positions that you go in today and you could have a job offer tomorrow, kind of thing. So.
That was very good. Thank you very much, sirs and Matt. So going forward, we'll let Zara present the video, and Dr. Ransom, actually, I'm so sorry. Dr. Ransom can go ahead. Thank you.
I will now share the video.
Zara, what happened? What did you say?
I'm just saying I will now share the video. Thank you.
Oh, okay.
At NASA Langley Research Center, what if isn't just a question. It's a challenge.
And liftoff. Here we go. Back to the moon and beyond.
It's we're wondering, what if we knew what's in the air we breathe becomes a cleaner planet for the next generation? We're wondering, what if we could make travel faster? Becomes a future where friends and family are never that far away. And we're wondering, what if we could explore deep space? Becomes the key to unlocking our universe's greatest mysteries. The future starts with a question. You just have to be bold enough to ask. At Langley Research Center, we put our curiosity and wonder to work, creating a better tomorrow simply because we dared to imagine it.
The impossible has become possible.
Our wonder changes the world.
We are the Science Directorate at NASA's Langley Research Center. Our science research is interconnected. No important question stands alone. Our organization includes about 350 of the most brilliant and equipped experts who are passionate about solving the world's toughest scientific challenges as we seek to better understand our home planet and beyond. Our interdisciplinary and highly collaborative work supports NASA's science goals and helps translate science to action. The missions, data, and science that have resulted from NASA Langley Science Directorate have fundamentally changed our understanding of Earth's climate, including the first long-term record of the vertical structure of the atmosphere from space.
just to get people's thought process going as it relates to just the opportunities. I think what if is a theme that we all ought to hold on to as we look to advance our careers academically as well as in the workplace. So that's all I wanted to show. I'll drop, I think, in the chat a few QR codes that you can look at and look at the opportunities that exist at NASA.
Space-based LiDAR. Our landmark discoveries in areas such as ozone detection and depletion have directly impacted global policy and facilitated management of Earth's natural resources for the good of human health and the U.S. economy. In 2023, our progress led to significant impact.
I wasn't sure if you heard. I just wanted to show the what if piece of the video just to stimulate thought as it relates to, you know, what we can do with our careers.
Okay, all right.
I'll drop some QR codes in the chat, I think, a screenshot, if I can figure out how to do that. So
You
that
can actually just screen share the presentation. That'd be way more practical.
actually, I was thinking not, because then that will require folks to have the cameras out, as opposed to if it were in the chat, they can look at it at any time.
Oh, right. Okay, I see the vision. Thank you.
Whatever your preference is.
All right, you can put it in the chat then. Okay.
Thank you, Zerb. Thank you, Dr. Ransom. And I saw a question in the chat, and I believe Dr. Ransom has actually answered it, and that was a good response. You can look into the chat; it's open to everyone. So going forward, there was a question for Dr. Walder. The question is, what kind of research do you do in NRL?
Well, NRL is a large organization. We range from, we too build spacecraft. Outside of NASA, I think we are one of only 2 laboratories that actually builds equipment that's launched into space, and we also operate the ground stations, in some cases for NASA, in some cases for other DoD customers. There's a number of facilities scattered around the DC area as well as around the world that serve as ground stations for space systems. We do a lot of oceanography, meteorology. We have divisions in California for meteorology. Our division in California is the claims, I'm sure there are many parents of this success, but claims to have identified El Nino effect in the Pacific, which impacts our weather so strongly. We have an oceanography division in Louisiana or Mississippi at Stennis Space Center. Does a lot of ocean, coastal, and submarine type research. And here in Washington, D.C., we have a very large group of divisions that do fundamental science, chemistry, plasma physics, electronics. To dwell on electronics, we have researchers who contributed to the electronics revolution through developing gallium arsenide, which is used in all of our cell phones. Also developed gallium nitride, which is another semiconductor technology that enables higher power levels. Material science, NRL was known for years and still is for material science work. So we run from academic level research, fundamental science, through applications, whether it's radar, electronic warfare, communication. Another invention of note is the dark web. NRL invented the dark web, the onion router, as a means to surreptitiously communicate from anywhere in the world without being observed by someone else. Of course, it's being applied for many other less noble causes, all in the service of security, though. So NRL is a kind of a unique place in the breadth and depth of work that we do. We are the only Navy laboratory the Navy operates warfare centers, which also do research. If you live in the DC area, you're probably aware of Dahlgren, where they do more applied research. And then there's the Army Research Laboratory, not far from the University of Maryland. Does research similar to NRL. So NRL, we're probably closest next to NASA Goddard to PG in terms of research type activities, but a wide range of things to include, supporting the infrastructure, the mechanical and civil and electrical engineers who support the base, keeping the base running. So there's opportunities for research, there's opportunities for infrastructure, and that cuts across the board just about in any activity or organization that you might end up working for.
Thank you, Dr. Walder. That was good. As a follow-up question, let me read it out exactly how it was typed. So the person said, I would like to bring group of high school senior students to visit the NRL. How is it possible? And would the person need to contact? What's the process about?
Yeah, that's an excellent question that I haven't been able to get an answer to yet. NRL is a defense research organization, and our security makes visits a little more difficult. We do STEM activities, but I haven't cracked that code yet. I'm sorry to say. So I'm still working on it, and I will share that information once I figure it out.
Thank you very much, sir. Adana, you can go ahead.
I'm sorry, Professor. Did you
May I say one thing? Mr. Walder, thank you so much for answering the question. That was not my question about tour to NRL, because I know I have communicated with you. Thank you. That was not my question. Thank you.
Okay, well, I'll retract my thought.
Yeah, it was actually, I must say Mr. Nemau. I'm so sorry for pronouncing that wrongly.
Yeah, I grew up just a few miles from NRL, and we keep ourselves all too secret, unfortunately. So but I am working on it. I think it's a great objective to expose it to the students in PG County.
Thank you.
Thank you so much, sir.
Thank you. I would like to give a personal thank you to all of our panelists who have gone into our meeting chat and answered any questions that they have seen. You have honestly been a huge help to us throughout this entire session. We do have a question from Mr. Felix. How much AI is used in the automation that you do?
Hey, so in my current role, we actually don't use AI. I mean, I know there is like automation jobs where you do use AI, but it's not that type of automation. It's more of like soft, like think of Python, right? Like it's just more of like code, and then we have sequential function blocks, and you just like, try to figure out code from there. However, we do have an AI team which is trying to, or I guess I don't know much about it, but they're trying to actually like implement the usage of AI somehow to like, ease or I guess help us troubleshoot, problems whenever they occur. So, but as of now, no, we don't use any AI.
Thank you.
Sure.
We are wrapping up our session in about 10 minutes. I did want to ask you guys, ask our panelists, I'm so sorry. If you could talk to your undergraduate or graduate self, what advice would you give to them? I'm sorry, Dr. Ransom, your mic is.
Maybe I was unmuted before and I muted myself. I'm sorry. If I could talk to my undergraduate self, I would say to take school more seriously. I don't want to imply that I got poor grades. I got excellent grades. However, I think I would have learned more had I asked more questions, spent more time studying the material after class, as opposed to just learning enough to get good grades. So I would tell myself to buckle up, learn the material, whether it's being taught in class or not.
Miss Ashley, we haven't heard from you in a minute. I just want to check.
Yeah. I honestly, since I finished undergrad so recently, I think not to like, if I were to give myself some advice, I think I really did do a good job, or like telling myself, taking a step back and realizing that it's kind of like a journey, to sit back and enjoy the journey. And I think I didn't realize that into like later into my undergrad years, so probably like finishing up junior year, entering my senior year, that hey, this could be so much more fun than what I anticipated it to be. So I think something that I did tell myself, but I realized too late in my undergrad years, to just enjoy the journey. And I think that's the best piece of advice I can give.
Thank you. I'm sorry, Professor Mennella?
What? Go to class. That's my advice. What I would give myself, get to class.
Thank you. Dr. James, Mr. Michael.
So, yeah, trying to think of something that one already said, but I mean, I guess a piece of it, don't be afraid to ask questions. Don't be afraid to ask for opportunities. We get very timid, or maybe very intimidated by that faculty member, that professor at the front of the room, and they can be potentially very helpful in suggesting paths to go, or don't be afraid to go speak to your advisors for what opportunities exist. So yeah, just don't be afraid to again put your hand up and say, yeah, I'll do that, or seek opportunities that exist.
Thank you.
I think that I would foot stomp on everything that everyone has already said, and I would add, for me, I think time management was crucial. Making sure that I spent my time effectively, setting aside time away from coursework, maintaining a social life, maintaining contact with friends, but also separating those two so that when it was time to study, I studied. Too often, I didn't have a cell phone next to me when I was a student. I can't imagine how easy it is to get distracted today. But time management, I think, is crucial, and it's crucial throughout your life. You learn that's another soft skill you learn in school that you're going to apply every day until the end.
Thank you so much. Mr. Felix, I believe you're our last panelist for this question.
Yeah, sure. Just to add on what the rest of the panelists have said, I think for me personally, I kind of rushed through UMD. I should have taken my time. Then again, it also depends on everyone's circumstances. Truth is, I did not really have to rush. I don't know why I felt that way at that time, but take your time. Don't rush through school. If you have to, okay, do it. But if not, then take your time.
Thank you so much. I believe for a final question, since we are running out of time, for all of the panelists, this student is a computer science major and they are specializing in machine learning. Would any of you think that artificial intelligence and machine learning could potentially play a significant role in your field?
So me personally, I'm working, as I mentioned, in kind of a niche field in electrical engineering with FPGAs. And I'm more particularly interested in like hardware. So in my field, we are more necessarily interested, how can we better improve like the GPUs or the CPUs used to power like AI and things of that nature. So it's more like a vice versa type thing. Like what can the technologies that I deal with on a day-to-day basis help improve AI and machine learning? However, in contrast as well, we can use AI or machine learning to help develop better tools to deal with these FPGAs and constructing this hardware that's built inside the FPGA. So it's very applicable to what I could, anticipated to be at the very least, both for hardware in AI and AI in hardware.
It's certainly AI/ML has generated a lot of interest, and there are plenty of applications to use it for radar. At its core, radar just makes a series of measurements, and we try to make decisions from the information gathered by the radar. And historically, those decisions have been made by human operators, and humans get tired, get distracted. They learn slowly, they forget quickly. So artificial intelligence and machine learning can be applied broadly in the radar field, in most information-related fields.
I can offer up if you like. I mean, AI and ML have applications, across the board in so many engineering fields at this point. Fire protection is certainly one of them, and providing improved detection systems, improved situational awareness, kind of the data for incident commanders, for the fire chief at the scene, just being able to better understand what's going on inside that building. It can be done through AI, and being able to incorporate all the sensor signals in. There's applications in wildfires in the same way of better understanding what the wildfire's doing, where it's going, when to evacuate that next community that's just on the other side of that hill. These kind of aspects. So just a couple of cases that come to mind right away in the fire protection field, where there'll be significant changes, I think, in how we do fire detection and how we provide information to the fire service. And then again, for the wildfire problem, that's a really an international problem, with that many of the continents are facing challenges with.
I would foot stomp what has been said thus far. I'd also add to that, and we've heard a little bit of mention of data. So data science, data analytics, data fusion is also key. The ability to interrogate a voluminous amount of data, whether it be simulation data, computationally based, or experimentally based, is critical. And using AI/ML to help us navigate through that large amount of data is also critical. There are a number of ways that NASA is using AI/ML. One of them is in the development of materials. One of the challenges that we have is developing materials that help us meet the needs of space exploration in the time that they're needed. And so developing materials more rapidly, having more information about the materials and their their behavior in different environments is also critical, and a place where we can use AI/ML to reduce the model size and also to help us understand the performance of said materials and the structural configuration. So I think, as was said, is critical to the engineering community as a whole.
So just to add, so I think in my role, since I'm involved in a lot of heavy troubleshooting, right? So it's more, I would say AI ML could help in the sense like, hey, you know, we're stuck at this part of the code, right? Like, how do we proceed from here? Like, hey, do I go check the pump? Hey, do I go, you know, look at a valve? Like, you know, these are stuff you have to, like, you know, manually go look at. So that's, for me, in my opinion, like, there is a lot more potential in my field and growth of AI.
I don't believe anyone else. Professor Mennella, would you like to give any input?
Yeah, I'm sure AI is going to replace me. There's no question about
it. Thank you, Professor. We are closing up. It is 5 o'clock. I understand that students will have questions for you guys, even out for our panelists today, even outside of our Zoom session. I was wondering if you all could put your contact information in the chat, emails, so students can personally talk to you and ask you any questions that they may have outside of today.
All right. Listen, I have to leave because I have a class to go to, but thank you very much.
Hi, may I take a moment? Thank you so much, everyone, for coming and helping our students and all of us. And thank you to our alumni. We are so proud and thankful that you are here. And everyone, thank you so much. That's it. That's all I wanted to say. I will give it back to Dahn and Oyendamola.
Thank you, Professor. I would like to thank you for being my co-student moderator today.
Thank you too. It's actually a pleasure to be a moderator for this amazing panelists and this amazing information just flying in and being able to like take in everything. Thank you so much.
Thank you.
I'd like to wish all the students success in your studies and your future.
Likewise. Always great to have an opportunity to chat. Great questions.
Thank you, everyone. It was a pleasure. Thank you for hosting, Professor Jabor, and the moderators. If anybody has any questions or concerns, feel free to message me on LinkedIn. Also, I know I saw a lot of internship questions. If you guys have any questions or need help with some resumes, you know, I'm always happy to help out a PGCC friend. So I also know that I know it's kind of like we're closing up, but I can also help you if you decide to transfer over to the University of Maryland. I can direct you to some like resources that can help with resumes and looking at internships. So always feel free to message me or something like that. Yeah.
Thank you. I would like to give a final thank you to our audience. Thank you so much for participating in today's session and giving a wonderful platform to our panelists today. Thank you, everyone. Be sure to check in the chat for our feedback survey. I will put it up again, and for all the contact information from today's panelists. Thank you.
Thank you.
Zareb, if you would like to close the session, at least our panelists can leave because we have already taken up their time. So have a good evening, everyone. Please feel free to go. I am so thankful you were all here and fantastic job, Adana and Oyendamola. Thank you.
Thank you.
Just give me a second. I'm just taking a bit of information. I will close the session in a minute.
Sure,
you.
sure. And you got your question answered, right?
Yes, ma'am, I did. Thank you.
Good job. Did you enjoy the session?
Definitely, I learned a lot. Thank you.
Good job.